Hello once again, our most developed student. My name is Confident and welcome to the continuation of our revision for Engineering Science N2. As I said, I'll be bringing you each topic by topic as we are revising, and we have done question 1 on dynamics, question 2 on statics, and we are now looking at question number 3, which is energy and momentum. So let me just erase this. So this is the question that I'm doing, and you guys, I just want you to follow me. If you are not subscribed, I will encourage you to be a part of the channel and subscribe. Now let's start with question 3.1. What is it saying? It says we need to define momentum. Now momentum, if we go to our formulas, let me quickly take you to the formulas and check if we have momentum, because the formula for momentum and this definition is just right there. I'm just checking it here. All right. Okay, I'm not getting it, but it's from its okay, I think I got it there. Okay, that's not the one. All right, anyway, just know that it's from the formula. How do you find momentum? Momentum, if P was momentum, is M times V. That's the formula for momentum. So if you are defining it also, you're going to say momentum is the product, that times is product, the multiplication sign is the product of mass and velocity. Okay, so this is the definition of momentum. So that is that. Now it says 3.2, that's the next question. It says a brick falls freely from rest. That's what we pick up there. It is falling freely, which means when they're saying it is falling freely, you must consider the effect of gravity, G. And now what is our value for G? You go back and I'm looking for this. Yes, what is our value for G that we must use? They told us that we need to use G as there it is, gravitational acceleration 9.8 meters per second squared. All right, so that is freely there. So if they're saying here the brick falls freely, so G there is 9.8. okay, from rest, that's another thing. If something is falling from rest, you must know that the initial velocity U is equal to 0 and has a kinetic energy EK. That's another information we're given there. Has a kinetic energy, which is our EK. All right, of that after falling 19 meters to the ground. So there is another information there. It is falling 19 meters to the ground. So the distance from, so what they're trying to say, if we can picture this thing, it's more like you have a brick that fell from there to there, and this distance here is what? This distance is 19 meters. So you have that particular brick there, you see, the brick that, okay, so there is a brick that is falling. Let me just draw it nicely. So you have something like this on the brick that is falling. So you have that. So it is falling down. Remember, it's going down. Now, the question is, when it reaches this point in this brick, that's when it would have fallen down. It would have fallen 19 meters. Okay. Then the first question says, calculate the velocity of the brick just before it hits the ground. So let's look at the formulas here for velocity. Now, if we are looking at, for example, we are looking at velocity, you have two options here that you can use, and the formula that we are going to use for this case, it is this formula, but I'm just going to explain it. So we're going to use this formula here, but we're going to change it because they didn't give us. And then the other formulas that are important is your potential energy and your kinetic energy. So if we are to use that formula, V squared is equal to U squared plus 2AS. Are you with me? So what you do here, you are saying that is question 3.2.1. Let's start there. 3.2.1. So we are saying V squared is equal to U squared plus 2AS. This is the best formula to use when they are saying here calculate the velocity of the brick. Now there is also the formula for EK, kinetic energy, that is velocity. It's half mv squared. Now the challenge is, if you already look at the question 3.2.2, it says calculate the mass of the brick, you see. So it kind of makes this second formula not the right formula, because it needs us to find the mass m of the brick. Are you seeing that? So now what we need to do, we need to say, okay, this is not the formula, but we have this formula, but we have to change it now. How do you change it? We are continuing to say V squared is equal to U squared, which is still fine, plus 2. Now they said it is falling freely, so the acceleration there is our g, so 2gs. You see that? Because that's the acceleration due to gravity there. And then with that, we can now substitute to say want velocity. V squared is equal to initial velocity. Remember, we said u was equal to 0, g was equal to 9.8, and s, which is distance. The s there is the distance, which we can change it to become h. Here you can change it to become h, which is the distance that is this object has fallen. It says that an object has a kinetic energy of that after falling 19 meters to the ground. So it says the velocity of the brick just before it hits the ground. So we are considering 19 meters as the distance traveled by this brick just before it hits the ground. So it's just somewhere there, you see, which is almost 19 meters. Okay, so s is equal to h, which is the height, which is equal to 19 meters. So when you do that, you will have 2 times 9.8 times 19. Now v, to find v, what do? You square root both sides. So v squared square root here is equal to square root, so that you get your answer once. 2 times 9.8 times 19. Alright, so we find then our v, which is the what? The velocity, which is the square root of 2 times 9.8 times 19. So that's what we have, equal to 19.297. 3 decimal places, 19.298. 19.298 what? Meters per second. So that's the velocity. That's the first question. Now we move on to 3.2.2. You see now, it says the mass of the brick. The mass, that's where we come back here and say it. Remember, I said there was the other formula 3.2.2. We had the other formula, which was what? Kinetic energy, EK, from the formulas is equal to half mv squared. Are you with me? And this, you get it from the formulas. If you check the formulas that we had, just to be there it is. You see, EK is equal to half mv squared, and potential energy is mgh. You need to know that these two general equations for kinetic energy and potential energy. Now there are two approaches here. You can substitute, but what I prefer, because is first making the other one the subject of the formula, because now we know our EK, you see, because they are saying here calculate the mass of the brick. Now we know that our kinetic energy here, EK, is 1,75, and then we know the distance, of course, but you can come here and say, since EK is 1,75 kilojoules, look at the unit kilojoules, so you need to change it. So which is 1,75 1,75 kg, which is equal to what? 1,75 times 1000. Don't forget that, which is now joules. Okay, you multiply by 1000 to convert that. So okay, that is fine. But now, since we are looking for m, we can make m the subject of the formula from the word go. So what we do, if you want to make the m the subject of the formula, we have got now to say your ek first, because it helps you to simplify easier. It's easy to simplify like that. So you multiply by 2 over 1 is equal to 2 over 1 times 1 over 2. So we are multiplying by the inverse, you see, by that. But what you do on the left, you do on the right, so that this can cancel. Okay, so that's what I just did there. So it's mv squared. So now e2k, which is 2ek, is equal to mv squared. So the next thing, what do? I just have to divide by, remember I'm looking for m, divide by v squared, divide by v squared. Then when you cancel there, you have got now your m is 2 times kinetic energy divided by velocity squared. Now the mass is equal to, then you have got 2 times the kinetic energy, we say it is what? 1,75 times 1000. Still remember, then that becomes joules over v squared. We just got our v, which was what? Which was 19,9298. So we've got 19,298. This is squared. Are you getting that? Then it gives us our m. So let's calculate that. It will be, in this case, 2 times 1,75 times 1000 all over 19,298 squared. And then you've got 9,398. Remember, you can round off with a calculator. Shift, setup, 6 is fixed, and into 3 decimal places, which is 9,398. So you've got 9,398. So now what is the formula? I mean, for this is kg, not the formula but the SI unit. So this brick is 9,398. Is it kilojoules, or I mean, is it grams or kilograms? The SI unit. Let me just check the SI unit here on the formulas. Just a moment, apologies. Yes, we measure everything in kilograms. As you can see, density of water, everything is in kilograms, as you can see. So I think I'm fine to use kilograms here, which is a heavy brick, which is 9,38 kilograms. All right, that is the mass of this brick. And then lastly, what is it? The potential energy of the brick when it is covered 12 meters from rest. Now you need to be careful here. The potential energy, that's where you need to be careful. Now, what is potential energy? It is energy due to position above the ground, you see. So it is, and then kinetic energy is the energy due to the motion of the brick. But potential energy, you have to consider the position from the ground. So it says the potential energy of the brick when it is covered 12 meters from rest. So you come here to say this brick has fallen down and covered what? 12 meters here, because this position is rest, and it has covered what? 12 meters. Now they want the potential energy, but potential energy, this is the starting point for potential energy. So for, if I say EP, you start from the ground. All right, that's the main thing. So you need to find now the other distance, to say what is the distance from the ground to that top there. So what will be the distance? Remember, it's 19 meters, so you expect this to be 7 meters. So that 12 plus 7, it gives us the total distance of what? Of 19 meters. So which means if we were to calculate the potential energy, EP, the formula for potential energy is what? When you're calculating potential energy, you are saying EP is equal to mgh. Now the height that you're going to use, we know the mass, which is 9,398 times 9.8, but the height, don't use 12. Don't use 12, no. They're gonna trick you. You must use what? The other one, which is 7 meters. Okay, so remember again my diagram. You are supposed to use the 7 meters, because why? When we are dealing with potential energy, we are starting from the ground going up. Kinetic energy, we are starting from rest going down. That's EK. It's falling from rest in a way, okay, and then it's going down. Potential energy is the energy of the object in reference to the distance from the ground. Okay, so it has got to do also with gravity. So then we get the answer here to say what is EP. It will give us the answer, which is 9.398 multiplied by 9.8 multiplied by 7, and then which is 644.7028, which is shift setup 3 decimal place, 644,703, which is 644,703, and it has to be in joules. 644,703. Are you with me? So this is the simplest calculation that you are supposed to use for potential energy. Now, when we've identified that, I think that's the end of this question. For kinetic energy, there is another method here, but it's too long. For this was 3.2.2.3. There is another method, but because of time, I'm just gonna leave it. There was a second method, but it's too long, where you're supposed to find the kinetic energy after 12 meters and subtract it from the top. But anyway, let's leave it like that. If someone, maybe, okay, let me just show you what you're supposed to do. You could have found actually here to say EK is equal to half mv squared. Now the kinetic energy gained, which is times 9.398, you need to find the velocity v here, and then you use that formula for velocity, which was v squared is equal to 2gh. You see, then from there, after finding the velocity, you put that velocity here, and the answer that you get, you are going to say 1,75 kilojoules minus the answer here. It was going to give you this answer here. So this is another method, you can try it out. So right guys, this is the end of the lesson, and I just wanted to say I'll be bringing all of these videos from question 3, 4, question 5, 6, question 7, and the last one I think is question number 8. Actually it's question number 9. So I'll be bringing all these videos, but what I want to make you aware is that most of them, yes, will be available to the channel, the 24-minute lessons, but the rest, if you want a full memo, you will see it also on the when I posted that. Sometimes you won't be able to view it because it will be, the full memo will be available to our premium members, and these are the people who are contributing to this channel. So if you want to become a part of this channel and you want to support it, you can become part of it by joining and becoming a premium member. There isn't much that you need to pay per month. You can just do it 1 month, and it's less than 100 Rand. And trust me, from what you're paying in terms of your studies compared to the 100 Rand just for you to get access to some of the videos which are not available to everyone on the public domain or on the public YouTube, it will help you for your final exam. So this is to say, why do we do that? Is to say thank you to our premium members, because you know, behind the scenes we need some equipment, there is always upgrade, there is always all that stuff. And remember, such things, they need money, so we cannot avoid that part. So we want to say thank you to our premium members as they support this channel through subscriptions. So if you want to subscribe, please feel free, subscribe right now so that you can have access to the full memo. It will be coming shortly, and once it is uploaded, you will be given a notification. That is when you are part of the we always tell you to say subscribe into the 24-minute lesson so that you get all the notifications. If you are not subscribed, unfortunately, you are going to lose out. So first of all, subscribe and then join for premium members. Thank you again for being part of the 24-minute lesson. We have come to the end of our lesson. Thank you.